tutor for today, and today I'm just going to be teaching you a little bit of tuples or tuples. Many people say many different things about them, so let's just get on with it. So a tuple in Python is similar to a list, but the difference is that a tuple is immutable, and we talked about this in my second or fourth tutorial. So in a tuple you could put anything such as listed here, but I wanted to just give you the advantages and the right about here. Since tuples are kind of similar to lists, both of them are in similar situations, but we use tuples for heterogeneous. Heterogeneous means different data types, and homogeneous means the same, something that's same from another thing. Since tuples are immutable, we get a performance boost because the iteration is faster. Tuples that contain immutable elements can be used as a key for a dictionary, which we'll be learning later. If you have data that doesn't change, implementing it as a tuple will guarantee that it remains write protected, meaning by no one can change it. So let's just say to make a tuple you have to use parentheses. So I'm not going to be using actual Google Colab. I'm actually going to be using something called rel. So I'm gonna go here, I'm gonna write Python, and then I'm gonna write tutor stuff. I'm gonna create the rel, and what this actually does is that I don't have to download any software, and it's still gonna run. It just takes time. Okay, so just to make sure that my compiler is in Python and not in anything else, I could just say print s, and it prints s, so it's a Python compiler. So in tuples we create them like this. So we say any identifier that we could name, and then we're just gonna get some parentheses in there, and then we're gonna write anything 1 2 3 4 5. Now when I run this, nothing's gonna happen. And now there's a difference between Google Colab and actual rope. The stuff that we've been using this entire time is actually IPython, an implementation of Python, but a little bit easier to understand and actually cooperate with. With actual Python, it's different. So let me give you an example. If I'm going to say a is equal to 10a, this is taken as print a for me. But if I copy the same thing, it's actually not going to do anything because it understands a, but it's not saying that it's going to print it. IPython can be much easier and it's good for automation, but we'll learn that later. So let me just Control Z. So if I say print identifier, so if I print identifier, it's going to say 1 2 3 4 5. That's pretty good. And if I want to slice it, I could just this means this is the counting step, meaning by how many steps it takes to the next integer until it is done. So it's going to go 1 3 5. And if I want to make it start on one digit, I could say start at 1. And what actually happens is that we talked in lists about the n-1 problem, and that if I want to actually get my third element, I actually have to type 2 in. If I want to get my first element, I actually have to write 0 in, because n is the actual number that you have to the actual term that you want, and you have to subtract 1 because the actual first element is stored as the first index or a 0. And if I want to start at something but not actually show it, such as 4, it's going 4 meaning by 5. So if I write 3, it's going to say 2 comma, it was about to say, but wasn't actually, because I said you can only stop at 4, but you can't do anything with 4 or after it. You can't do anything with the third element or the elements after them, only with the ones before it, with the starting and the last one. So we could even do negative slicing. It's the most fun thing that people do. It's actually important. This actually gets these individual elements and gets the first one, and then when it's done that, it prints like this. It's called a negative step. This is good for us, but sometimes not that good. Now, let's just see what happens if we do this. This means that your step will be negative. You'll actually do your stuff with this, and you'll leave the last element. Now if I say the starting is -1 and I do this, you're gonna see 4. Why? Because 4 is the last element. Okay, so let's just take this out. Now we could test if there's something inside. So we could just say we need a Boolean expression, right? So we could say if, we could say 1 in identifier. Let me get this because, okay, let's go here, print something. So actually what it's gonna do is that get the integer 1, any random integer, which is actually 1, and iterate through the list and see if it actually is there. So if I say 1 right here, you're gonna see something. So let's just go over here. Now if you want to delete a tuple, we could do this. Now, you could see here that it says that identifier is actually not there, because what happens is that I deleted the entire memory of identifier, which is sometimes good for us if we want to manipulate lists, and when we're done with them, we don't want to store them. So today we learned about a tuple, and I just wanted to say, unlike a list, you can't